Using the table, we'll be looking into some of the basic functions of Laplace transform. A common function found in a standard Laplace transform table is 1. Here's an example. Laplace transform of 1 would be equal to 1 over s. If you were given Laplace transform of 4, the answer would be 4 over s. Another example, negative 5 would be negative 5 over s. Here we look at another common function. Laplace transform of t is equal to 1 over s squared. If you were asked to find Laplace transform of 3t, it will be equal to 3 over s squared. Another example, Laplace transform of t squared will be equal to 2 factorial over s 2 plus 1. That would equal to 2 factorial s over 3. One last example. Again, another function. That will equal to 1 over s minus a, which is 4. Here's another example. Now, if you were asked to find Laplace transform sine 2t, you just replace the k with 2, so what you'll get is 2 over s squared plus 2 squared. For cosine, however, it will be s over s squared plus k squared. So if you were asked to find cosine half t, the answer, still replacing k with half, will be s over s squared plus k, which is half, squared. Here we look at another function that is straightforward. If you were asked to find Laplace transform of t e for t, that would equal to, just punch in whatever you see, s minus 4 squared, replacing with 4. Here's another straightforward function. So if you were given t cosine t, that will equal to, note that this is 1 times t, which gives you 1t. So 1 is the k. So just replace that, you'll get Alright, this is just something you should note, that Laplace transform of t is 1 over s squared. So earlier on, we did Laplace transform of 4, which is equal to 4 over s, right here. And Laplace transform of 3t is 3 over s squared. So if you were given Laplace transform of 3t plus 4, your answer would be 3 over s squared plus 4 over s. Another example, if you were given at plus b, your answer, a over s squared plus b over s. It's similar. Another example, if you were given 1 plus e4t, which we also did earlier on, e4t, your answer would be 1, Laplace transform of 1 is 1 over s, plus e4t, just replace, would be 1 over s minus 4. Now the last part of this video lesson, I'll be teaching you a first shift theorem. watch closely on how to solve this. We're gonna do Laplace transform of this sine 2t, letting s be s minus 7. That's where 7 comes from. So sine 2t, Laplace transform sine 2t would be equal to, let me think, 2 over s squared plus 2 squared. Copying this down. So that would equal to 2 over, so because we let s equal to s minus 7, we're going to change this s to s minus 7 square root 2 plus 4. Here's another example, negative this time. So again, we'll find Laplace transform of this sine t, letting s be s minus 1, because this is minus 1 times t, which is equal to minus 1t. We're just putting this in there. So Laplace transform of sine t would be equal to 1 over s squared plus 1 squared. Copying that down. Now again, because we let s be s plus 1, so s now becomes s plus 1 square. 1 square is 1. So now that we've learned to use the table to solve the Laplace transform of some common functions, we could get a question like this. So what you do to solve it, just by parts, Laplace transform of 2.5 over s of t plus 1 over s squared minus now right here is the first shift theorem. So that would, you take out this, Laplace transform of e to t is Laplace transform of t, letting s minus 2. It will always be s minus the constant there. So that would equal to 1 over s squared, letting s be s minus 2. So the answer will be s over, since we've let s be s minus 2, so it will be s minus 2 squared. Over here, there is no shift, so we would times it over here. So it will be e to the power 3 times t squared, which is 2 factorial over s power 3. I'll give you another example of a no shift, which is Laplace transform of e t plus 7. That would equal to Laplace transform of, if you separate them, it would be et times e7. So just like this earlier on, it doesn't have any shift. So how we solve this is we take the one without shift, that would times et, which is in the table, it is 1 over s minus 1, which will give you this.